Welcome. So in this part, we'll discuss the idea that we need to adjust our cost estimate from a project to a project. So we'll learn why we need to do that and the different approaches to adjust the cost estimate to account for different locations and different time of the projects. So in the first part, we discussed the process of three main functions of cost management. So you do the estimate, you budget, and then you control. And you do that based on cost data that you collect from previous projects or from data sources that you have available for, you paid for, and these come from different projects, different backgrounds, different conditions, different times. So you need to uh, adjust these data to reflect the new conditions that you will see in the future projects. So this is a first example here. Is a water district is building a new plant, and it did have data for similar project 10 years ago. Are the cost data still applicable? You can say in some extent yes, but 10 years is a long time. A lot of things could have been changed, or the cost of things change over time. Another example here, if you're contractor working in one location and you're doing exactly similar project in the same year but a different location, what the data you have from the first locations are applicable to the second one? You can see where I'm going with that. No. So you have to adjust building in, south or the Central Valley in California is completely different than building the same thing in San Francisco Bay Area or Los Angeles. So you have to adjust your cost estimates to account for two main things here: the time adjustment and to adjust for the location. So why you adjust when you have old cost data? Because inflation. The same thing I bought it $1 2 years ago will cost me now $3 4. Why? Things the purchasing power of a dollar is generally decreases over time. So the thing here, we can adjust for inflation, assuming that there is no big change in technology of doing the same thing. So if I'm doing a concrete column, I didn't have like robots building it now. I didn't have it 10 years ago or 20 years ago. It's still the same construction methods applied, maybe some improvements in the equipment, but still they're not significant. So the main thing I'm adjusting for is the purchasing power of the money is decreasing over time, but I'm trying to say that construction methods did not change that much. Otherwise, then you will have a completely different construction method, and then the data are not for sure applicable. So you adjust for the time, but what we call construction cost indices. A construction index is a metric that shows and models the change of the price of commodities over time. A cost index series usually starts with a value of 100 at a basic year or a base year. And it's just a value that represents the cost or expenses of main commodities at 1 year. It's not a dollar value, it's just a value unitless. But the key here, the change of this value will allow you to change your estimates or dollar values for commodities over time, so you can adjust your cost data. Different cost indices are published by different entities. So, for example, private entities like contractors have their own way to track cost over time of commodities, and they produce their own indices. So Turner is a big company, Mortison. There are many companies are doing that. They have good, rigorous cost tracking practices, and they can leverage that to have their own cost indices and even detail it by region, like we see here for Mortison. Another publicly available way to adjust for cost accounting for the time is ENR cost indices. It's actually the most and I think up to my knowledge, it's the most utilized cost index out there. Always people refer to ENR as the main reference in the industry. And the idea here, that's pretty old, it's just up to 1996, up to even exactly March 1996. And the base year here is 1913. So that's more than a century ago. But you can see here 100, and this index is keep growing. Just keep going up, baby, like that. So until it reaches in this time here, March 1996, 5,537. So you can say that the ratio between this 5,537 and 100 is the same ratio of the cost of the same item now, or 1996 and 1913. This is more recent chart showing the cost indices all the way until most recent 2018. I'm recording the video here 2020, but I don't have the subscription to get the latest with ENR, the latest data. And you can see here it explains how ENR is calculating this index. It's tracking the main commodities in construction. You can see here like structural steel, labor, cement or concrete, lumber. So they kind of doing it instead of commodities like eggs and vegetables and fruits, you're actually collecting commodity prices that are used in construction. Another source is RS means. So like we said in the first part, we'll use RS means as one of the reference that we will depend on explaining cost estimate. So RS means kind of also organize or reports historical cost indices that can be used to adjust costs. And this is just one page, and they are detailing it by main cities and main regions. And the average by the national average is here. So this is just a page of many pages in the book. So how now to use these indices? So let's say you have a cost in the past, cost P, and you want to calculate the cost in the future or the present, cost F. So you'll get from the tables the cost indices for the past year and the future year, and use that ratio to adjust your previous cost value. So for example, if you have this equipment, this turbine, you bought it 2000 with for 2 million, and you want to buy it again in 2018. So from ENR tables, if you go back to back in the video, go back and see what values there are. So cost index of 2000 was this, 2018 is that. So your cost of this turbine from 2000 to 2018 almost doubled in cost. Now for location adjustment, so you adjust for geography because every region, every metropolitan area have its own supply-demand dynamics. So in San Francisco, Chicago, New York, these big metropolitan area, there's a huge demand there, and the supply cannot usually match it. So the prices there are higher than somewhere like in Wisconsin, or I'm not picking any states or cities, but you got the point. So so here you need to adjust for location, and this is a table from RS Means showing the city cost indices. This is one part of one page of many pages, because you're reporting here for Wyoming, for example. The main cities in Wyoming, and if you remember in master format, RS Means is following master format. So you remember the divisions. We have 49 divisions. Concrete is there's 3, masonry is 0.4. So you can actually adjust the cost per division from different locations, or you can adjust it just the total. So the average weight here for all type of work and all divisions, you can use just one this last row here. Another thing you can adjust by focusing only on adjusting the material prices between locations, or the installation, the labor part of it, or just having a total kind of average of both. So if I think Newcastle, Wyoming, the city index there is 84.1. Kind of, it's around 16 digits below the average national. I didn't know about Newcastle, Wyoming, but it's city somewhere in Wyoming. If we compare it to San Francisco, California, city index is 122.5. So now, if I want to adjust my cost from a project that I did in Newcastle, Wyoming to San Francisco, I can use the ratio between these cost indices. So it did cost me 75 per square foot for a masonry unit in Wyoming, Newcastle. It will cost me around 50% more to do the same square foot of that masonry wall. So that's the idea here. In summary, you mainly adjust for two things. You adjust for the location, LI, and you adjust for the time using the cost indices that you have. So pay attention to what cost data you have. Probably it's the average national cost data, or if your company is local, then just use it. You don't worry about location. But time is really critical, because over time you build experience, but the data you have in the system or in this book that represent experience of doing this work, to reuse that experience in future projects, you have to adjust for the difference in time and inflation. So that's the end of this part. So we learn about how to adjust for time and location in your cost estimates. So see you in other parts of this interesting lesson.